Hello, good morning, everyone. My name is Reginaldo Luna. I am master student and I'm author of paper with title mini batch with first training and testing for data streams processing of the editor. This work have as objective to explore improvements to better use of shared memory on classification data on data stream user educated computer. So, first our agenda. I will first talk a bit about motivation of this investigation. After, I will speak about with data strings, ensembles, and voltage frequency scaling and correlating performance improvements. And then talk about our results in energy consumption, efficiency, energy, and latency and performance predictive. Finally, show our conclusions. So, information technology industry released more 2% of total CO2 in atmosphere last year. And this number will increase next year. Will be expected in next year in 2030, ICT industry demands 30% from energy world. In, in this other picture, we can see a projection. In this other picture, we can see a projection from energy to ICTs, where will project to increase in 20% in 2030. And in bad case, this number can be 8%. This data show the us, us a possibility to explore alternatives to our project in ICT. Think in green compute and reduce consumption energy. So, talk about data strings, ansibles, and voltage frequency scaling, and core limit. Machine learning in energy consumption reduction has been an integration being trained in machine learning because more and more we using models in machine learning and deep learning in daily. And this reflects in more consumption of energy and two options to explore new technologies. For example, we can explore IA in real-time data analysis, healthcare, stock market, and others. We can use tool in ethical computer, Internet of Things, and use with batch learning processing, with data lakes, big data, or string processing. What's the difference between batch learning and string learning? Basically, batch learning is used when two fully trained data are available. The algorithm makes a decision model after processing the data many times, while with string learning, data become in time execution where potentially infinite editors cannot store data for a single pass. So, having some challenges as limited computational resource in terms of memory, CPU, and power. Christian learning exists a popular strategy is to ensemble several models using BAG. Although, although Bang, although Bang, although Bang, although Bang, although being proposed of 25 years ago. Bagging remains an effective method for reducing error without resort to complex model. Third, as deep neural networks, there are not trivial to train and fine-tune by utilizing the Poisson distribution. Bagging creates several different subsets of the data to repeatedly train with some instance while ignore others. enhance its efficacy. This, we use six ensemble algorithms that evolved from the original bag to align string, setting by using and Rehearsal. What's challenge? How to accelerate ensemble of classifications in data stream, and string learning, and use on the ethical computer and IoT devices. How to process more instances and better use cache misses and cache references, thus improving performance and energy consumption. First, alternative is execute classroom as parallel mode, but when use parallel execute, us lose in reuse memory and performance. Well, what to do about it? Before, what's options in DVFS, and DPM to find an improvement energy and performance? We also evaluate mini batch strategies, both the original and the improvement one. By comparing them to other strategies supported in commodity processors. First, Talent Power Managed GPM can be pro- programmatically enforced to save energy. GPM encompasses many techniques to save energy and dynamic power. Second, most, most microprocessors nowadays can automatically turn off the clock of inactive components to this end. If there are no float point instructions for execution, the clock of the float point unit can be disabled. These changes in processes possibility see options to reduce consumption energy and improve performance when compared strategy with mini-batch. Now, I will speak about improvement done on algorithms type mini-batch. To contextualize, batch techniques consist of grouping instances of a dataset and processing them together. The technique can be applied in different contexts for different purposes. Mini-batch is commonly used in deep learning where the trained data is divided into small subsets called mini-batches. By using batches, standard of process on data instance and are time. The training process becomes more efficient and memory-friendly. Limiting batch her reference to a specific optimization for improving the data locality of backend symbols, as defined in Casales et al. 2021. The mini batch strategies group several data streams of a string into small chunks, named mini batches. To be processed by earth learning of the ensemble, earth learning is a executed parallel task that iterates over all the instances with a mini batch. We proposed an improvement to mini batch as described in algorithm 3. There are separate loops for the classification lines 3 and 6, and training lines 8 and 17 on the batch instances. We can see in algorithm 2, these modifications enhances cache reuse by performing both the classification and the training all single pass. In this case, the data structures will be loaded in the caches and reused for both the classification and training operations. Second, reduce loop overhead. Last, in algorithm 3, the training operations is executed after all the instances of mini batch are classified. Thus, causing a short delay in model training. By first these phrases with loop frozen standard, the classification and training occur with the same iterations, line 3 and 6. reproducing the original behavior of the original ensemble algorithms, which perform both the classification and train operations with the same processing in the relations. Now, about the results and experimentation evaluations. Experimentation evaluation. Our experimentation evaluations consists of analyzing the data results of energy consumption. The output processing each instance, the use of cache miss and cache reference, and finally the predictive performance. To this, we use a Raspberry service to process the instance using the USABag, adaptive reinforced, LBag algorithms, and others. Using the mini-batch technique and the improvement of mini-batch loop fusion and action to parallel use with changes in header. To obtain energy consumption information, we use DebScaled Yokogaha MW100 that provides data in watts transformed into joules so that we can analyze energy consumption. Using cache miss and cache reference, we obtain the results of the Unix 2 kernel perf. And after running 10 times for each configuration, we analyze the data that will be shown below. First, we will analyze results in throughput and energy reference. This graph, we see two bars, blue and R, EPS, and red JPE. In highlight products, we can see configuration of algorithm ARC, adaptive reinforcement, and dataset GMSC, and airlines. We can see apparent results when using MBLF method with more JPS and minus JPE in our results. Energy efforts and data classification latency also significant improvement when comparing MBLF results with previous mini-batch. Results and hardware techniques for reduce energy consumption. Hardware energy consumption reduction techniques used when using for available cores and also increase latency time. However, when user more cores into a higher frequency, energy consumption increase and latencies choose do. On the other hand, on the other end, the use of MBLF mini-batch with loop fusion improves in all cases, both in latency and energy consumption. This is, this is due to better utilizations of chamber memory, which we'll see the results of the next slide. We can see an improvement in cache miss and cache reference for the mini-batch loop fusion implementation when compared to sequential version and mini-batch without loop fusion. There is less memory access and better access to challenge memory. And finally, the predictive reshoots. When we implement loop fusion in mini-batch algorithm, we also find an improvement in the performance of the data classification prediction. In our experiments show that mini-batch outperforms the hardware strategies in terms of throughput and energy efficiency in all of the test cases. Pure mini-batch improving energy efficiency, the amount of work performed by the same energy consumption consumed by 96% on average and 169% in the best case. Mini-batch with loop fusion proposal in this paper improving energy efficiency by 136% on average and 456% in the best case. Software strategies support better control of the application of the optimizations without after all the applications that execute on the same time. As future work, we evaluate to investigate adaptive best settings to balance latency, energy consumption, and accuracy under prior loads. These are references used in this presentation. Thanks. If any some question, I'm happy I try answer, but can be I don't understand. If the case is thing, I am happy answer for email after presentation. Sorry for mistakes in English.